Today we're going to look at using some of these equations on the chemistry equation sheet. So you'll notice on this equation sheet we have masses measured in grams, we have moles, and molar mass. Now the last video posted had showed how to calculate this molar mass. So molar mass measured in grams per mole. And so we'll review that quickly and then how to use that molar mass in these equations. Now when it comes to moles, what does moles mean? It was explained in the PowerPoint video, but as a reminder, a mole is defined by Avogadro's number. So looking at Avogadro's number, that's this number here, 1 mole is equal to 6.022 times 10 to the 23rd. And the word after this times 10 to the 23rd is entities. What entities means is entities can be several different things. It could be atoms, it could be molecules, or it could be formula units. So we use the word atoms in place of entities when we're talking about an element by itself. So for instance, going to the periodic table, say we were talking about carbon, C. So if I wanted to know how many atoms were in 1 mole of carbon, I would use Avogadro's number. So 1 mole of carbon would have 6.022 times 10 to the 23rd atoms of carbon. So that's a lot of atoms. Notice this number, times 10 to the 23. It's a positive exponent. That means we take this decimal point and we're moving it 23 times to the right. So a huge, huge number. But atoms are very small. So it makes sense that there would be billions upon trillions of them present in just a small amount. So how do you know when to use molecules and when to use formula units in place of this entities? Well, to figure that out, we need to know what an ionic compound is and what a covalent compound is, because we're going to use molecules when it's covalent and formula units when it's ionic. So to figure that out, if it's covalent or ionic, let's look at the periodic table. So here's your periodic table. Now this periodic table is separated by a zigzag line. You can see this line here. I'm going to outline it in green. So the reason for this zigzag line is they're separating the periodic table into metals, nonmetals, and metalloids. So everything to the right of this zigzag line, but not touching, these are going to be the nonmetals. Everything to the left of the zigzag line, so all these guys are going to be metals. Now the semi-metals, or the metalloids, those are going to be the elements touching this zigzag line, with the exception of aluminum. So I'm just going to color in all the metalloids. So all those green ones, those are the metalloids, the semi-metals that have properties similar to the nonmetals and the metals. So how are we going to use this to figure out if a compound is ionic or covalent? Well, for an ionic compound, remember a compound is 2 or more elements combined, we can identify it as ionic because it's a metal with a nonmetal. So for example, if you're given a chemical formula, in this case, LiBr, you would find these 2 elements on the periodic table, and based off the arrangement of the periodic table, you would be able to tell if these 2 elements were metals or nonmetals. So looking at Li, lithium. Lithium's over here, number 3 on the periodic table. So that means it's a metal. It's attached to Br, bromine. When I find bromine, it's number 35. And since it's to the right of the zigzag line, it's a nonmetal. So since I have a metal with a nonmetal, it's an ionic compound. So when I'm using Avogadro's number, my entities is going to be formula units. Okay, well, what about a covalent compound? how do I know if it's covalent? This would be a nonmetal with a nonmetal, or a metalloid with a nonmetal. So an example of this would be CO2 or SiCl4. So these are two different examples. Carbon, right here, number 6, nonmetal. Oxygen, number 8, also a nonmetal. So since they're two nonmetals, this is a covalent compound. And when I'm using Avogadro's number, the 1 mole is equal to 6.022 times 10 to the 23rd, I'm going to use the word molecules in place of entities. The other example, silicon tetrachloride. Silicon's a metalloid. Chlorine's a nonmetal, so it fits under this heading. So it's a covalent compound as well, and I would once again use the word molecules. So now that we have the basic wording figured out, let's look at some problems. So we're going to be looking at number 2 here. So how many moles of propanol, and they're given the chemical formula right there, C3H8O, are there in 42.1 grams of propanol? Okay, so we're using this equation sheet to figure it out. So it's asking us to solve for moles. That's the question mark. It's giving us grams, and remember, grams is a mass. So we're going to look at our equation sheet. And we need an equation sheet that that has both moles and mass. So this one has moles and mass. This one has moles and mass. The ones down here we don't want to use because it's not talking about entities at all. It's not asking for atoms, molecules, or formula units. So I'm not going to be using Avogadro's number. It's got to be one of these top two. Now these are actually the same equation, just rearranged, so either of them would work, but I'm going to pick the one where moles is equal to, so I don't have to rearrange it. So to solve for moles, I'm going to take the mass in grams and divide it by the molar mass. Well, notice when we read the question, we said the mass is this 42.1 grams, but they didn't give us the molar mass, and that's oftentimes going to be the case. So why didn't they give you the molar mass? Because you need to calculate it. So we learned how to calculate molar mass in the last video based off of the chemical formula. So if I want to calculate the molar mass of C3H8O, what I'm going to do is I'm going to make a list of all elements present in this chemical formula. I have carbon, I have hydrogen, and I have oxygen. Next, I write how many atoms of each. So to figure out how many atoms, we're looking at the subscripts. So this 3 that's after carbon, that means there are 3 carbon atoms. For hydrogen, 8. For oxygen, just 1. Now I'm going to take these numbers and I'm going to multiply it by the molar mass, or the average atomic mass, that I find on the periodic table. So going to the periodic table, I'm going to find carbon. The atomic mass, the molar mass, is this number down here, 12.01. For hydrogen, its molar mass is 1.008. Oxygen, coming back over here, we can see it is 16. So multiply across and then add all of those numbers together to get the total. Three times 12.01 plus 8 times 1.008 plus 16. So I get a total molar mass of 60.09. That should be 0.01. Now the units on molar mass are grams per mole. So I have the mass of 42.1 and I now have the molar mass of 60.09. So I'm going to plug those numbers into the equation I chose. So putting the 42.1 on the top and the 60.09 on the bottom. Notice my grams are going to cancel because they're on opposite sides of that horizontal line, leaving my units as moles. And that's good. That's what I want. I'm looking for my answer in moles. I get to 3 sig figs, because we're only looking at the significant figures given in the problem itself, 0.701 moles. Let's look at another problem. So next we have number 3 asking us to calculate molecules. And they are giving us the moles, 0.166 moles. So now that we're looking at molecules, so whenever you see the term atoms, molecules, or formula units, you're going to be using Avogadro's number somewhere. So it's one of these two equations. In this case, they use the word molecules because CO2 is a covalent compound. Carbon's a nonmetal, oxygen's a nonmetal. 2 nonmetals tell me it's covalent. So which equation do I want to use? Well, they're asking us to solve for molecules. That's the question mark. So we want to pick the equation where number of molecules in this case is equal to. So we're using number of molecules is equal to the mole amount multiplied by Avogadro's number. So here we just need to plug in that molar amount and multiply it by Avogadro's number. So 0.166 is going to go where this mole is, and then we're going to multiply that by 6.022 times 10 to the 23rd. Notice moles are canceling, leaving the units of just molecules. I get 3 sig figs again, so 9.9, that's going to round up. So 10.0 times 10 to the 22nd molecules. So that's how many molecules are present in that sample. Quite a few. Right, let's move on. So let's now look at number 4. So how many atoms of chlorine are needed to mix with silver to make 5 moles of AgCl? So they're using the word atoms, so I know Avogadro's number is going to be used. And they're giving us the mole amount. So this is the same as the previous question. We pick the same equation, except for this time, instead of writing number of molecules, I'm going to write number of atoms, since we're talking about an element. Chlorine's an element by itself. I'm going to take the mole amount that they gave us and multiply it by Avogadro's number. So plug in my 5 moles. Multiplying that 5 times 6.022 times 10 to the 23rd will tell me just how many atoms. And I want 3.0 times 10 to the 24th atoms of chlorine. All right, let's look at number 5. So this one's going to be a little bit more difficult because it's a multi-step one. So we have how many molecules? So notice we're using the word molecules, so we're going to use Avogadro's number at some point. They're giving us mass. And notice this hint here. It says start by calculating the molar mass of iron 2 sulfate and then calculate the number of moles. So whenever we're solving for how many molecules or how many atoms, like up here, we're going to be using this equation here. But notice when we use this equation, we need the mole amount of the substance. And they didn't give us the mole amount of the substance. What they gave us was the grams. So that's why our first step is going to be converting that grams into moles so that we can plug it into this equation here. So I'm going to start by calculating the molar mass, just like the hint says, of iron 2 sulfate. We'll learn how to name these guys too in the next chapter. So I'm going to make my list of all the elements present. I have iron, sulfur, oxygen. Using the subscripts to figure out how many atoms of each. If there is no subscript, like after this Fe, I assume there's just one atom of iron. Same goes for sulfur, there's just one. Oxygen has a 4 after it. What goes in this next column is I find all those elements on the periodic table and find their masses. So for iron, 55.85. For sulfur, 32.07. For oxygen, 16.00. Multiply across and add them all together. 32.07. I get a total molar mass of 151.92 grams per mole. So this is my molar mass. Now I need to somehow use my molar mass and my grams to come up with moles. So it's the first problem we did. If we want the moles, we need the mass, which was given, 122, and we need the molar mass, which we just calculated. So writing this equation down to figure out the moles, I'm going to plug the mass in the numerator, 122. I'm going to divide it by the molar mass that we just calculated, 151.92, so that my grams cancel and I'm left with moles. I get 0.803. So this is the molar amount that I'm going to plug into this equation so that I can figure out molecules. So 0.803 times Avogadro's number. .84 times 10 to the 23rd. I ran out of room, so I'll write molecules down here. All right, let's try one more. So in this last one we're going to look at, we have the American Heart Association recommends no more than 0.039 moles of salt, which has the chemical formula of sodium chloride, per day. We're going to calculate the amount of salt that can be consumed in grams according to the recommendations. Okay, so this time they're giving us moles, and they're asking us for grams, grams being a mass. So they didn't say molecules, they didn't say atoms, they didn't say formula units, so we're not using Avogadro's number. It means it's going to be one of these top two equations. This time they gave us the moles, so we're going to use the second equation because we're solving for mass. So we want to use the equation where mass is equal to. So mass is equal to the moles, 0.039, times the molar mass. Now they don't give us the molar mass, but they give us the chemical formula, and we can use that to calculate the molar mass. So for sodium chloride, we have sodium, Na, and chlorine. How many atoms of each? Just one. There's no subscript, so we assume just one. Looking up their masses on the periodic table, we have sodium being an alkali metal here, 22.9. We have chlorine being a halogen in group 17. We get 35.45. So my total molar mass (58.44 grams per mole). So we can take this and plug it in to that equation. So to solve for mass, I'm taking the moles that they gave us, 0.039, and multiplying by the molar mass that we just calculated. Notice this time, moles and moles cancel, leaving us with the units of grams. So 2.28 grams. So that's how many grams of salt the American Heart Association recommends per day, no more than that. All right. Well, next week we'll be looking at how to name compounds. So we're going to use what we learned to identify elements, or to identify compounds, excuse me, as either covalent or ionic, based off of if it's a metal with a nonmetal or two nonmetals together. And then we'll move on to learning how to name them based off of their type as well.